Okay, so we recently had an incident with my Whiplash where lost all control in flight after rebuilding it from a crash, and we're trying to figure out why. So we're doing some electrical tests to prove things out. So this machine is set up with Futaba electronics, 7008 receiver, all Futaba servos, and a Bavarian Demon gyro. For onboard power, we have an A123 battery along with an engine-driven generator, Raja's Joule generator. So the battery is connected through a switch to the receiver, and whenever that's turned on, you get 6.5 volts. And the engine, whenever the engine is running, the generator spins up and is generating 6.9 volts, which goes into two inputs, one into the gyro and one into the receiver. So it works like a car electrical system, where it just basically whenever the engine's running, the generator's going and it's keeping the battery float charged. So in flight, the odds of a complete power loss are very low. An A123 battery pack can take dozens of amps, no problem, and the generator has a constant output of something like 3 amps, and we measured about a 2 amp average load. But what happened was, in a hover, the helicopter just suddenly shot up, and then we lost all cyclic and collective control because the gyro failed to respond. The receiver was still live, so I was able to do throttle hold because throttle bypasses the gyro, goes straight from the receiver to the governor. That was done on purposes of safety, which saved us. Killed the engine and the thing floated down. But the question is, why did we lose control? So what happened was, once we got to the crash site, the gyro was flashing a 3 red blink, which indicates it couldn't initialize because it detected movement while it was initializing, which would seem to indicate that it power cycled and rebooted in the air. And when it booted back up, helicopter's moving, can't initialize, so the servos stay discharged. But we can't figure out why, because I'm not able to reproduce any power failure on the bench. I've attempted moving the wires around, looking for shorts, jiggling things, vibrated the whole frame. I actually used my Dremel and bent a bit to make a big vibrator, and ran it and would touch it to all the electronics, looking for some kind of intermittent short vibration. Nothing. Load checked the battery, put 2 amps on it with a Hanger 9 load checker. Only got like a half a volt of drop, and that was on the receiver side. At the battery, it only drops like a tenth. And the reason for that, unfortunately, is that there's a lot of losses through the switches. But we know that, and that's why we use 3 different inputs. So in flight, you'll never see that as long as the generator's running. It just basically sits at 6.9 all the time. So what I have set up here is a little test. I've got the radio turned on. We have telemetry enabled with a 1/10 of a second update interval and a 1 second logging interval. And I also have the load checker plugged in the receiver. So I'm going to hold the helicopter still and power up, and we'll see everything initialize. Oh, sorry, disconnected. So I just reset there. Going to power up. And you can see gyro just initialized. So the gyro is good. Now hold the head, move the sticks, see everything's working. See the gyro is properly initialized and correcting. All right. Now what I'm going to do is show you the readouts. So we see 6.45 on the meter, 6.5 on the telemetry. It rounds up. It's fine. I'm going to stir the sticks and put some load on. See it's dropping. The lowest I've seen on the telemetry is blipped at 5.9. Right? But I never saw less than about 6.2 right there. Now let's do a load check. Let's do a 1/2 amp. 6.2. And then see, we get a little bit of a high reading on the telemetry. that's possibly because I'm using a long piece of wire here for the checker, and we've probably got some serious voltage drop through all these connections. Let's go to an amp. So 1 amp load check, 6.02 and 6.3 the receiver on the telemetry again because we've got some voltage drop. Good. Let's do a 2 amp load test. 2 amps. Oh, so we dropped to 5.6 at the load checker, but it's still holding over 6 at the receiver. I don't want to do this too long because my voltage checker will get hot. But anyway, you can see that it's really holding voltage pretty good. Another thing I can do is, it's kind of hard to do holding the phone. I'm stalling the servos by leaning on the head, and I'm doing 2 amps. Look at that. Now I get 5.8 at the receiver and 5.3 at the load checker. I'm probably pulling 4 or 5 amps here, stalling the servo and using the load checker. But the key is, nothing rebooted. Everything's still holding good. Right? Yeah. Wiggle the wires, wiggle all the wires, wiggle the wires, wiggle everything. I looked, I don't see any cuts. You know, here's the, right here, this is the generator motor. And this is the, it generates 3-phase AC, AC to DC rectifier, which then comes down here to a DC regulator, which regulates it to 6.9, and there's 2 inputs, one to the gyro, one to the receiver, and then the receiver also has an input from the battery. So there's a lot of power inputs, a lot of paths for power to get to the gyro. All the connections are glued, so they won't come out in flight. This gyro it's a newer one I got, because I moved my older one to a different helicopter, but it's got at least 50 flights on it. It's never had a problem. You know, physically everything looks good. It's an older battery, but A123s live forever. I've got some that are 10 years old that still work. I don't use them in the air, but they work. So I'm going to pause for a second, and then we're going to do another test. Okay, here's my second test. So I disconnected the A123, and I plugged in this battery, which is an old Futaba transmitter pack, 5-cell and IMH, which I haven't charged in ages. It's 4 or 5 years old. It's very tired. I retired it, and I just keep it for testing. But we're going to power up with this because it's got very low voltage right now, which you'll see in a second. So, ready? Going to power up. Alright. Everything initialized. And notice, we've only got 4.2 volts, but the gyro initialized. Now the buzzing you're hearing is the radio low voltage alarm, and it's also gone into battery failsafe. So you can see we switched to green because I have battery failsafe programmed to put us into horizon mode. But the gyro is still working and correcting. Right? Other thing you'll notice, servos still work. Oop, it's flipping on me. So here we go. Look at this. Servos still work. 3.3 volts. Servos are still responding. So the question was, could we have browned out in flight? Well, you could see there was no way I could get it much below 5.8 volts, putting all the load I can imagine with the battery I have. And that's assuming the generator wasn't working, which I've tested in this. But even if it did, getting down to just over 3 volts, and I still get a response. Let's do the load check. What's this? 2.7 volts. 2.7 volts, and I still... Oh, there we go. It's dead. The gyro isn't responding. But once it got power back, it just shut down reaction. When I go to 2.7 volts, it shuts down reaction, but it didn't power off completely. When I let go, it comes back to 3.5 volts, and everything's still responding. Even if I do that, put the load on at 2.8 volts while I'm moving it, take the load off, moving it, servos are still working. So having the voltage drop to like 3 volts in flight even wouldn't have done it. I mean, just look at that. Servos moved down to almost 3 volts. The receiver is responding. still got a green light, you know, at 3.5 volts, right? So I don't think it's a power problem, which leads me to suspect there's something going on with the gyro. So it's going back to Germany.